All right, everybody, this is the promised video for today where we're going to look at Descartes' rule of signs. So this is when you're still dealing with polynomial functions and when we're trying to find the real zeros that could possibly be. So Descartes, I think we said that this could be someone's grandpa, was this mathematician long time ago, which tends to be the case around 1637. And he noticed that then when there is a variation in sign, that tends to correspond with the number of real zeros that a polynomial has. So there's two ideas behind this when you are exploring a polynomial. So the number of positive real zeros of p of x is either equal to the number of variations in sign or less than that by an even whole number, and I'll explain what that means. And then the number of negative real zeros of p of x is either equal to the number of variations in p of a negative input, negative x, or is less than that by an even whole number. And so we're going to take a look at this example right here to determine the possible number of positive and negative real zeros of the polynomial. So let's jump over and take a look at this. So if I'm looking at this polynomial, when I say variation in sign, it means when I go from one term to the next, that it's either it's switching from a positive to a negative or a negative to a positive. So I look at my first term here, and I notice that I go from positive to positive, so there's no change in sign. My second term to my third term, I notice I go from positive to positive, so there's no change. My third to my fourth term, though, I go from a positive to a negative, which means that there is a variation in the signs. And then from my fourth to my fifth, you'll notice I go from negative to negative, so there's no change. Okay, so what does this tell us? What this tells us is that this polynomial has one positive zero. So what this tells us is one variation has one positive zero. Okay, so then the second half of this is to check if there's any negative zeros in this function. So the way that we check that is we put in a negative x in for our input. So I'm going to write all of my inputs as parentheses right now, and then you'll see why. So I'm just rewriting this polynomial minus, actually, I'm really bad at trying to write smallness. All right, let's try this again. Okay, so what I'm going to do is instead of having x in there, I'm going to write negative x and see what happens. Okay, so once we do that, then we evaluate and we see what we get. So p of negative x is going to be any negative number to an even power. So negative x to the sixth power is just going to leave us with x to the sixth power. And anything to the odd, we're going to end up with negative x times negative x, which gives us positive, negative x times negative x, which gives us positive, times negative x, which gives us negative. So we're going to have a negative 4x to the fifth. That's going to occur here as well. Negative times negative is a positive, times negative is a negative. And then here we've got positive or negative times negative, which is positive, plus x minus 3. So now that we've done that, we've evaluated p of negative x. We've got this in here. We're going to take a look at the sign changes. Okay, so we go positive to negative. So that's a variation. Negative to negative is not. Negative to positive is a variation. And positive to negative is a variation. So here we've got three variations. So let's write this out. P of negative x has 3 variations in sign. Therefore, P of x has either 3 or remember it's every even amount underneath. So 3 or 1 negative roots. 3 or 1 negative roots based on Descartes' rule of signs. So what that makes is for real roots, that means we either have, so we know that we have one positive real, 0 for sure. So we have one positive real, one positive, and we have either the choice of 3 negative or 1 negative. So what that means for us is we either have 4 real roots or 2 real roots in this specific function. And that's the information that Descartes' rule of signs gives us.